We conclude Learning Workbook, page 225, with this problem about radioactive decay. The mass of a radioactive substance follows a continuous exponential decay model with a decay rate parameter of 2.5% per day. Find the half-life of this substance, that is, the time it takes for 1/2 the original amount in a given sample of this substance to decay. Do not round any intermediate computations, and round your answer to the nearest hundredth. Okay, so once again, a big block of text. Let's go ahead and pick it apart little by little. First thing it says is round your final answer to the nearest hundredth. So that means that our final answer will look like this. Something in front of the decimal, and then 2 digits afterwards. Next it says do not round any intermediate computations. So that means that we're not going to do any rounding until the very end of the problem. If we round in the middle, it introduces error, and then as we continue to work with numbers that have been rounded, the error could get much, much, much larger, resulting in us having a wrong answer. Next, it says the half-life of a substance is the time it takes for half the original amount of a given sample to decay. Let's talk a little bit about half-life. Let's imagine you start with 10 grams of a substance. What would be half of that? 5. How did you get that? Divide by 2. 10 divided by 2 is 5. Let's say you start with 1,000. What would the half-life mass be? 1,000 divided by 2 is 500. Let's say you started with 1,000,000. What's half of that? 1,000,000 divided by 2 is 500,000. Now, what if you don't know the initial amount? What if the initial amount is just a variable, like x? Well, then the amount that you would have when you're looking for the half-life would be half of that, x divided by 2, or the fraction x over 2. That's going to be useful as we solve this problem. Okay, so now we've talked about the half-life component of this. And that clears up some space for us to solve this problem. So let's begin. Here we go. The first thing you want to pay attention to is that this is a continuous exponential decay model. So we're going to use this equation. A of t equals a naught e to the kt. The next thing we want to pay attention to, and this is extremely important, is that this problem involves decay, not growth. So when we find the value of the variable k, it's going to be negative, not positive. Negative 2.5%. Okay, so let's put everything in the problem. We know the mass of a radioactive substance follows a continuous exponential decay model with a decay rate parameter of 2.5% per day. So 2.5%. Remember that percent is a mathematical constant that's always equal to 0.01. So this gives us 0.025. And because it's decay, when we put it into our equation, we do so with a negative value. So we're going to have e to the negative 0.025t. Now, as for the other values that are in our equation, you'll notice that the only number they give us is 2.5%, and yet they ask us to find the half-life. This is where we need to remember the discussion we had about half-life just a moment ago. A naught is the initial amount. It's the amount you started with. If you want to find out how much time it takes for that to be half its amount, what that means is that the amount in the future, a of t, is going to be a naught divided by 2. So they do not have to give you a starting amount in order to solve this problem. You just have to understand that whatever you start with, a half-life length of time later, the amount you'll have will be half of the starting amount. Okay, so now we're going to go ahead and solve this problem. So the first thing we're going to do here is to recognize that both sides of our equation have this a naught thing. And a naught divided by 2 is the same thing as 1/2 a naught. So, as we now attempt to solve this for t, we recognize that we have a multiplying value in front of our base, and we have to get rid of it. So we're going to divide both sides by a naught. When we do, the a naughts cancel on both sides of the equation, and we're left with 1/2 equals e to the negative 0.025t. This is an exponential equation of type 2, and the way we solve type 2 equations is by taking the logarithm of both sides. Since we're asked for a decimal answer, we can choose log base 10 or base e, since we'll be using our calculators. But as with many problems before this one, the base of our equation is e, so we'll take the natural log of both sides. So we have the natural log of 1/2 equals the natural log of e to the negative 0.025t. We get the natural log of 1/2 equals negative 0.025t. If you're not sure how we got from here to here, please watch the previous videos in this sequence. I have 2 examples that show the algebra that supports why this and this are equal. Divide both sides by negative 0.025. And we get our exact answer for t. T is exactly equal to the natural log of 1/2 divided by negative 0.025. But we need a decimal approximation for this, so we'll pick up our calculators. Let's begin. So I'm going to hit my n over d, make a fraction button. I'll put in natural log, 1 divide 2, close parentheses, down arrow, negative 0.025, enter. And what I see is 27.72588, etc. I need to round this to 2 decimal places, and so I get 27.73. And since this is asking me for time, the length of time, and this says per day, this is representing the number of days. So this is 27.73 days is the half-life of this particular substance.